Hello there. In this video, I am going to solve some MCQ type questions on renewable energy. Well, in the quiz, you have to select the best answer and I will pause the problem for some time and go to the answer. However, you can pause as you wish and continue with your own timing. You have 50 questions and plan for 1 hour. Question number 1. Which of the following energy resource is renewable? Coal, oil, nuclear, natural gas. They all are non-renewable resources, whereas tidal power or tidal energy is the only renewable resource here. Question number 2. Work and energy. So the unit joule is associated with only work and energy. The unit of both work and energy is joule. If you take the following resources, ocean wave, hydropower, geothermal energy, solar thermal energy, they all are renewable. Which of the following energy resources is non-renewable? Natural gas is the answer. From the following, select the non-greenhouse gas. So carbon dioxide, methane, water vapor, ozone. They all are considered to be greenhouse gases. So the only non-greenhouse gas is nitrogen. Question number 5. So the which of the following is considered as a direct greenhouse gas? You can see oxygen, nitrogen, argon. They all are non-greenhouse. But you have a choice between sulfur dioxide and nitrous oxide. So definitely nitrous oxide is a direct greenhouse gas. Sulfur dioxide has a minimal effect, but it is considered as indirect greenhouse gas. From these resources, nuclear power plants produce almost no greenhouse gas emissions during its operation. You have to select the best answer. If you take natural gas, oil, biomass and coal, for sure they emit greenhouse gases. What is the most abundant renewable energy resource on the earth? So solar energy. If you take others, you have to select the best answer. So solar is the one. How much energy is delivered if a hydropower plant is continuously operating at 100 megawatt for a period of 6 hours? So you know the energy. If you want to calculate the energy, you need power and the time. The power is given as 100 megawatts. You can convert into watts. and the time is 6 hours. But if you see the answers, it is in kilowatt hours, one answer. You have to convert watts into kilowatts and keep the hour term or the kilowatt hour unit, and you will get the answer number C. In general, why is renewable energy important for the present and future? So if you look at all these answers, like it's a clean form of energy, it will not run out, it has zero fuel cost, low maintenance requirements. So all these features are associated with renewable energy. So the answer is E. Question number 10. We know that if you want to calculate the efficiency, that is the output over input, you have to find out the output. So it is directly given delivering a 6 megawatt of electric power. So that is the output. And what is the input? So you have a loss. So the input would be the output plus the loss, in other words 16 megawatts. So if you want to calculate the efficiency, output over input, you know the output, that is 6 megawatts. Your input should be 16 megawatts. And then you have to multiply by 100 as a percentage. So you will end up with 37.5%. A solar photovoltaic cell can be approximately modeled to a diode, not a transistor, not an IGBT, not a MOSFET. So the answer is A. What is the input power to a solar PV panel if panel area is 1.5 square meters and solar irradiance radiation is 900 watts per meter squared? So if you want to calculate the input power, that is, you have to multiply by the area into the radiation. So area into the radiation, that is 1.5 into 900, you will end up with 1350 watts. In other words, 1.35 kilowatts. The answer is D. So we have to find the output voltage. If you see, there are two sets of panels. You can see the first set, the five panels, first five panels, they are in series, and another five panels, they are also in series. So if you want to calculate the voltage of these five panels, if they are in series, you have to add the voltage. So 42.5 into 5, you have 5 panels, so we'll end up with 212.5 volts in the first set. So next you have another set. So once you combine these two sets in parallel, the voltage won't be changed. So 212.5 will remain as the voltage between the points X and Y. So your answer will be C, 212.5 volts in the system. Question number 14. Now you will see there are 5 panels in series. So each panel is producing 5.5 ampere current. So you will see the same current is flowing through each panel. I mean the first 5 panels. So 5.5 is going to be added to the main branch. So you have another set in parallel to the first 5 panels. So that will also, I put here as I2, that also 5.5 amperes. So these 5.5 in the first branch, that is I1, and the second branch current I2, 5.5. So these two parallel branches will inject a total current of 11 amperes to the main branch. So your final answer is 11 amperes. So the answer is in here B. Question number 15. What are the components needed to have an off-grid solar PV system? Of course, you need solar PV panels, charge controller you need, but not an amplifier. So your answer is D. What is the main component needed for a solar PV system with net metering system? That means your system is going to be connected to the grid and you want to sell your power to the grid or to the utility. So the main component here would be grid tie inverter. You need charge controllers and battery banks. These are for off-grid systems. What is the typical efficiency of a good solar PV panel? You have to be very careful here. You will find in the current market even 10% efficient panels or even 5%, but a good solar PV panel, so that would be around 20%. It can be 18%, 22%, but not definitely 40% panels you will find in the market, or definitely not 80% at all. So your answer will be C. You have to select the best one. What are the two main solar PV charge controllers available in the market? So it is MPPT and the PWM. So PID and PD controllers, they are general control algorithm names, but microcontrollers and programmable logic controllers, they are different types of controllers not using in these solar PV systems as charge controllers. So answer B is the one. What is the maximum power point of the solar VI curve given below? So if you take the point V or Z, the power is 0 because you have to, I am taking a point V. So your current is approximately 6.5, but the voltage is 0. So your power would be finally close to 0. So if you take point Z, the same, you have 0 power. So now you understand Wxy. So you will find if you take these voltage and current values, you will end up at point X with the maximum power. So answer is C. What is the unit used in general, right? So in general, for measuring battery storage capacity, so in general it would be ampere hours. If you take your car battery, so you will find the unit as ampere hours, but sometimes in large battery banks you can have the unit kilowatt hours. So don't misinterpret this answer. So it is ampere hours, that means from the given answers, right? What form of energy is extracted by the blades of a wind turbine in order to produce electricity? You know, the wind, the moving air is kinetic energy, not the potential energy, not the radiant, thermal or chemical. So your answer is B. Which type of generator is used in wind turbines? Depending on the applications, right? So you might use DC generators, sometimes induction, sometimes synchronous, but it depends on your application or the scale of power you are looking. So all the above types. Question number 23. What is the output power of the wind power generator if it has the following parameters? Blade length, that is 25 meters. You need actually the turbine diameter, so that would be 50 meters, and the power coefficient is 0.55. Wind velocity 8.5 meters per second. Air density is given 1.25. So gearbox efficiency or the transmission efficiency, that is 90% or 0.9, and generator efficiency, that is 91%. So your power will be pi over 8 rho, that is the air density, V wind velocity, D the diameter, and Cp is the power coefficient, and Ng in transmission, so they are generator efficiency and gearbox efficiency or transmission efficiency respectively. So you can put the values, you will end up with approximately 340 kilowatts. So your answer is coming in watts, so you have to select the best answer here. What device in a wind turbine is physically connected to the electrical generator? So you will see low speed shaft, high speed shaft, gearbox, turbine shaft, and all these components. So what is physically connected? So that's the key thing to the electrical generator. You know, the low speed shaft is not connected to the electrical generator. You need high RPM to get the desired output of the generator. So you need, it's a high RPM. So to get that one, generator is connected to the high speed shaft. What is the blade tip speed if a wind turbine is rotating at 27.5 rpm and the blade radius is 35.5? So you need the diameter again, and that is 35.5 multiplied by 2, that is 71 meters. rpm is given. So if you want to calculate the blade tip speed, so that is 5d into the rpm divided by 60. So you will end up with 102.23 approximately. The answer is D. What is the common type of collector used in large solar thermal power plants or CSPs? Of course, evacuated tubes and parabolic dishes and flat plate collectors. They are all collectors, but they are not used in large scale power plants. So, parabolic troughs are the ones used in large scale solar thermal plants. So the answer is D. Question number 27. This can function as a large scale thermal storage unit in solar thermal power plants. So what kind of thing you are looking? You can store the things in large solar thermal power plants, right? Not definitely nickel, cadmium and lithium ion. They are related with the battery technologies. So water can be as a storage, thermal storage, but from the answers given, the best one would be molten salt. Can function as a large scale thermal storage unit, right? What is the output power of solar thermal power plant with parabolic troughs if the plant has following operational conditions? So plant efficiency, so whatever you are receiving as input power, the output will be the efficiency times the input power. So you will find one collector area, that is with the collector dimensions you can find 25.5 meters squared. So that is a collector. N is number of collectors. You have 5,000 collectors. You know these plants are large thermal solar power plants. So you have large number of collectors. Because your efficiency is very low, you are looking a large area. So your solar irradiance, so the radiation is 900 watts per meter squared. In other words, DNI, daily normal irradiance. So that is 900. So you put in this formula all these values. Efficiency 21%, it can be 0.21 into these values. You will end up with not in small scale power output, so it is not even in kilowatt range. So that is 24.1 megawatts approximately. So your answer will be D. Question number 29. What is the reflector type used in solar power tower based CSP technology? So it is very particular reflector type. You have a name, it's called heliostats, not parabolic dishes, not flat plate collectors or parabolic troughs. So answer is C. Question number 30. Which one from the following uses two-dimensional tracking in order to maximize solar yield? So parabolic dishes are the ones you can have two-dimensional tracking. Question number 31. What is the input power to the following solar water heating system from the solar radiation? So let me explain this system in another way. You can see it's a solar water heating system. So definitely the energy is coming from solar energy. So you can see the power per unit area or solar irradiance or radiation, that is 950 watts per meter squared, that is coming to the collectors. You have 25 collectors, and if you take the dimensions, that is 2.5 into 1 meters, 2.5 meters squared. So the input power is going to be area multiplied by the radiation. So area, you have to calculate the total area. That means one collector area 2.5 square meters into 25 into the radiation. The radiation value is 950. You will end up with 59,375 watts that is 59.4 kilowatts approximately. The answer is D. Question number 32. What is the heat absorption rate in kilowatts? In other words, rate of heat gain of the following solar water heating system when water is heated from 20 degrees to 55 degrees centigrade in 9 hours. Specific heat capacity of water 4184, water tank capacity 9000 liters. So you know, when you heat from the solar energy, finally your heat will be transferred to the water. So let me explain the whole picture now, as in this diagram. You see, your input energy is coming from the solar radiation, that is from the collectors, and then you transfer that heat or thermal energy to the water. So you have 9000 liters, in other words 9000 kilograms. You know, the heat absorption is the amount of heat, that is the famous equation mc theta. M means the mass, c, and the theta means the temperature difference. So you have the temperature difference, that is 55 minus 20, that is 35 degrees. But M 9000 kilograms, but here it is asking the rate of change of the heat, or in other words, you can see here it's asking absorption rate in kilowatt, that's in power. That means you have to divide by the time, or when you put in this equation m dot, that is mass flow rate, 9000 divided by 9 hours, and also you have to convert into seconds, you divide by 3600, so you will get m dot. So now you have m dot, you have cp, and the temperature difference. So as a summary, the heat coming from the solar radiation, that is irradiance 950, the energy is received by the collectors, and that is transferred to the water, and water is uh, heated up from 20 to 55 degrees. So what is the rate of heat gain or absorption rate in kilowatts? You have m dot, now already calculated m dot, and cp 4184, and temperature difference, and that is 35. So you will end up with 40,677.77 watts, in other words 40.67 kilowatts. So your answer is A. Question number 33. what is the efficiency of the following solar water heating system when the water is heated from 20 centigrade to 55 centigrade in 9 hours? The same story, but they're asking what is the efficiency. So it's a nice way to understand what you mean by an efficiency of any system. So let's try to understand. Now you see your input and output, that is what you need for any efficiency calculation. So input power is the solar energy or solar power. So that is coming through the collectors. So we already calculated that one. And our output, your energy is transferred to water. This is what? Hot water. You need hot water from the solar energy. So your input is solar power, that is 59.4 kilowatts, we already calculated. And what is your output? So your output power or output is in the water, right? So that energy, output energy or output power in the water tank, the hot water. During the process, you have different types of losses and different energy components are going out from this system, right? So that's why there is a loss and related efficiency. So what is your output? You already calculated what is the uh, heat gain in the water, that is 40.67 kilowatts. So you know your output, that is in the water, in other words the hot water, your output. Your input is 59.4. If you want to calculate the efficiency, you get your output and divide by the input, multiply by 100. So you will end up with 68.5, and you have one answer here, and the answer C is 68.5%. Which heat transfer fluid or thermal carrier would be used in CSP plants and solar thermal systems? Glycol, molten salts, liquid sodium, they all use as a heat transfer fluid or thermal carrier. So your answer is D. With the current technology of CSP, what is the maximum possible temperature of a practical receiver in a solar power tower? So practical receiver means your material should be able to withstand against this high temperature. So you cannot have a temperature like 10,000. So that answer is out. And of course you can heat your receiver beyond 10 degrees and 100 degrees. So your answer will be C. Question number 36. In general, what is the turbine type suitable for high water head? So that is the key word here. High water head is associated with Pelton turbine. So not Francis Coupland bulb. So if your hydropower station producing hydropower is going to have a kind of high water head, that is associated with Pelton turbines. Question number 37. What is the net water head of a hydropower plant when the plant is delivering 50 megawatt at an efficiency of 88%? Note that density of water is 1000 and G is given as 9.8, water flow rate is 12 cubic meters per second. So if you want to calculate the power, you know the power of a hydropower plant will be G times the rho, the density of water, into the efficiency, into the water flow rate Q, into the head, water head, or in other words the effective water head. So what is going to have here, power is given as 50 megawatts, that's going to be G times 9.81 times 1000 times the efficiency 88%, that means 0.88, into water flow rate Q, that is 12, into the water head, net water head or effective water head, that is H, that is what you need, and finally you will end up with 482.6 approximately. Your answer will be 483 meters, that is answer D. Question number 38. What shows the correct energy conversion flow of a hydropower plant? You are looking into the energy conversion flow. So when you store your water in a high potential area, or in other words in the reservoir, we call it a potential energy, and you try to bring that to the uh, towards the turbine, that is kinetic energy, and finally you generate your useful electrical energy through the generator. So potential energy to kinetic energy to electrical energy, answer D. Question number 39. What would be the best option to support a power grid if you have many intermittent sources? That means your sources are in the nature of varying, like wind power or solar. So you have to have a stable power source to supply your loads. In other words, to stabilize your grid, you need the generators like hydro power generators. So if you can have a storage of water, you can use the hydroelectricity. So we call it pump storage hydroelectricity in this kind of situation. So best answer from the given ones uh, is answer D, because all other sources, if you look into, they are in the varying nature. Question number 40. What power category would Pico Hydro plants fall into? So Pico Hydro means very small scale power producing plants. So they might be below 10 kilowatts or sometimes even below 5 kilowatts. So your answer is E. Tidal energy is a result of the surge of ocean waters during is none other than the rise and fall of the sea levels, right? So the answer is D. Question number 42. As you know, tidal energy is a form of hydropower. So the tidal phenomenon or occurrence is due to, so we are looking here what is the phenomenon. So it is gravitational pull of the moon and the sun. So due to the gravitational pull of the moon and sun, the water levels in the oceans going up and down. So this is the phenomenon behind. Question number 43. Ocean thermal energy conversion, or we call OTEC technique, would use the temperature variations with ocean depths, right? It's not the temperature variation with the river depths or pressure changes or whatever. So answer is A. Question number 44. Which of the following reaction or reactions would associate closely with a fuel cell? So if you say, take the first reaction, that is anode and cathode reactions in a fuel cell, whereas number C or answer C is separation of this is nothing related to a fuel cell reaction, right? So answer A and B are correct. So in other words, your correct answer is D. Question number 45. If you take a car or vehicle with a fuel cell, so what is the energy flow, right? So it's a chemical reaction which gives you energy, and it is going to store in a battery or form of electrical energy you can use later. So and then when you turn your wheels, when you drive your car, that is kinetic energy or mechanical energy. So chemical energy to electrical energy to mechanical energy is the energy conversion. Question number 46. Geothermal power plant uses Earth's internal energy, and it uses not the gas turbines, hydros, boiling water reactors, which are in nuclear power plants. So steam turbines are the standard turbine type which are being used in geothermal power plants. Question number 47. What is the most common cycle used in geothermal power plants? So it's binary cycle, you have two cycles. The first cycle, the bottom one, taking the geothermal energy or thermal energy from the source and transferring to the normal Rankine cycle, the steam turbines to run. So you have two cycles. In some plants you have other different cycles, but most common one is the binary cycle. Question number 48. Why biomass is considered as a carbon neutral? This is the word, this is the key word in this question. Carbon neutral. Generally, though it emits CO2 during any combustion process. So when you burn, definitely it will emit carbon dioxide, but it is carbon neutral. Why? Right? So if you take a particular tree which is going to use in the biomass process, so as a biomass, finally you are going to burn or a kind of combustion process. How this carbon neutral thing is happening, when the tree or that plant is growing, right? So it removes carbon dioxide from the atmosphere, right? Not these answers like biomass produces less carbon dioxide comparatively, biomass produces useful gases, right? Even though you use biomass in a combustion process, but during the full cycle, plants remove CO2 from the atmosphere, right? So that is why it is considered as a carbon neutral. So it's a very important thing. Question number 49. A carbon footprint, or in other words, total amount of greenhouse gases produced, can be defined to what kind of situation, like an individual or an organization or service or a product. You can have all the above to define a carbon footprint. Question number 50. What storage system would be useful to make a reliable grid system? So, if your grid should be reliable, or in other words, if you want to have a reliable grid, in other words, your sources should not fluctuate or kind of unreliable, right? So if you can store your energy in large storage systems, so you can have a good reliable grid system. So what are the storage we are looking here? Hydrogen storage. You can have pumped hydro storage system. That's another, like a battery, large battery energy storage, another system, and it will be very useful in we are not talking the small scale battery storages, but for a grid you need large scale storages, and of course thermal energy storage systems, especially with the CSP technology. So all these are possible. So what storage system would be useful to make a reliable grid? You have to select the best storage system, or which so all these are right possible storage system. So answer E would be the best answer here. I think you enjoy, and it will be useful, and if you need the PowerPoint or the PDF file of these questions, you can read the description and email to me. Thank you.